Good morning, everyone. My name is Teja from CSC Data Science C section. Today, my physics topic is an introduction to quantum key distribution. Topics: Introduction. What's a quantum computer? How quantum computers threaten conventional cryptography. Quantum key distribution and its impact on the telecom world. How does quantum key distribution work? Types of quantum key distributions. Outline of the review. These are the topics to be covered. Introduction. While the word quantum has only started trending in the technology space during the last decade, many past technologies already relied on our understanding of the quantum world. From lasers to MRI imaging, electronic transistors, and nuclear powers, the reason quantum has become so popular lately is that researchers have become increasing better at manipulating better at manipulating individual quantum particles, light light photons, electrons, atoms, in ways that were not possible before. These advances allow us to harness from more the unique and weird properties of the quantum world. They could launch yet another quantum technology revolution in areas like sensing, computation, communication. What what's a quantum computer? The power of quantum computers comes chiefly from the superposition principle. A classical byte can only be in in a 0 or 1 state, while a quantum byte can exist in several 0 and 1 state combinations. When one when one measures and observes the quiet, it will collapses collapse into just one of these combinations. Each combination has a specific probability of occurring when the quiet co- collapses. While while two classical bytes can only exist in one out of four combinations, two quantum bytes can exist in all these combinations simultaneously before being observed. Therefore, these bytes can hold more information than a classical byte, and the amount of information they can hold grows exponentially, which with each additionally quite 20 bytes can already hold a million values simultaneously, and 300 bytes can store as many particles as there are in the universe. However, to harness this potential processing power, we must understand that probabilities in quantum mechanics do not work like conventional probabilities. The probability we learn about in school allowed only for numbers between 0 to 1. 1. On the other hand, me- probabilities in quantum mechanics behave as wave with amplitudes that can be positive or negative. And just like waves, quantum probabilities can interfere, reinforcing each other or cancelling each other out. Quantum com- computation computation as an interference process. The, the quantum circuit processes all the potential possibilities, cancelling out the wrong solution and reinforcing the correct solution. How quantum computers threaten conventional cryptography. Today's digital society depends heavily on securely transmitting and storing data. One of the oldest and most Most widely used methods, uh, used methods to encrypt data is called RSA, Rivest Sharmir Eldman, the surnames of the algorithm designers. RSA, RSA encrypts messages with a key that results from the multiplication of two very large numbers. Only someone who knows the values of these two can decode the message. RSA security relies on the mathematical principle multiplying two large numbers in computationally easy, but the opposite process, figuring out what large numbers were multiplied, is extremely hard, if not practically impossible. For a conventional computer, however, in 1994, mathematician Peter Shaw proved that an ideal quantum computer could find the prime factors of large numbers exponentially more quickly than a conventional computer, as thus and thus break RSA encryption within hours or days. While practical quantum computers are likely decades away from implementing Shor's algorithm with enough performance and scale to break RSA or similar encryption methods. The potential implications are terrifying for our digital society and our data safety. In combination with private keys systems like AES RSA encrypts most of the traffic on the internet. Breaking RSA means that emails, online purchases, medical records, company data, and military information, among many others, would all be more susceptible to attack from miscellaneous third parties. Quantum computers could also crack the digital signatures that ensure the integrity of updates to updates to apps, browsers, operating op, operating systems, and other softwares, opening a path for malware. These security threats has led to heavy investments in new quantum resistant encryption. Besides existing private key system used in the enterprise telecom sector like AES 256 are already quantum resistant. However, even if these methods are secure now, there, there is no guarantee that they will remain secure in the future. Someone might discover a way to crack them just as it happened with RSA. Quantum key distribution and its impact on the telecom world. Give these risks. The most secure way to protect data and communication is by fighting quantum with quantum. Protect your data from quantum computers hacking by using security protocols that ha- harms the power of quantum physics laws. That's why that's what quantum key distribution does. Quantum key distribution uses to generate a secret cryptographic key protect, protected by the phenomenon phenomena of quantum state collapse. If any if an attacker tries to drop and learn information about the key, they will they will distort the irreversibility. The sender and receiver will see the discord as errors in their measurements and know that their key has been compromised. Quantum safe encryption will take part people's day-to-day life through upgrading laptops. How does it work? Quant- Quantum key distribution works by transmitting many light particles or photons over fiber optics cables between parties. Each photon has a random quantum state, and collectively the photons sent maybe make make up a make up a stream of ones and zeros. This stream of ones and zeros are called qubits, the equivalent of bytes in a binary system. When a photon reaches its receiving end, it travels through a beam splitter which forces the photon to randomly take one path or another into a photon collector. The receiver that responds to the original sender with the data regarding the sequence of the photon sent. In the sender, they compares with the emitter which would have sent each photon. Photons in the wrong beam collectors and discards what's left in the specific sequences of bit. The bit sequences can they can can then be used as a key to Krypton data. Any errors in data leakages are removed during a phase of error correction and the other post processing steps. Delayed privacy amplification is another post processing steps that removes any information might have gained about the final secret key. Types of quantum key distribution: prepare and measure protocols. Prepare and um, prepare and measure protocols. Enhanced based protocols. Prepare and measure protocols focuses focus on measuring unknown quantum states. They can be used to detect envelope dropping as well as how much data was potentially interpreted. Based protocols focuses around the quantum states in which two objects are linked together, forming a combination quantum state. This the concept of uh, entanglement means that measurement of one object thereby affects the others. If an accesses as previously trusted node and changes something the other involves particularly, parties will know how photons impact quantum key distribution. Photons, photonic quantum key distribution devices has been in some shape or commercially available for over 15 years. Still, factors such as the high cost, large size, and inability to operate over longer distance have slowed their widespread adoption. Many of them many of them efforting regarding quantum protocols, the size, weight, and the power limitations. One way to overcome these limitations and reduce the cost per devices in every quantum key distribution function, generating, manipulating, and detecting photonic into a single chip. The further development of the integrated quantum photonics chip is considered by many as a critical step in building the platform that will unlock quantum applications in the way such as integrated circuits transformed microelectronics. Outline of the review: new hardware such as a chip based quantum key distribution and new software such as novel protocols are being studied and developed. The security of partial quantum key distribution systems is another important challenge. In order to foil quantum hackers, protocols such as MID, QKD, and loose tolerant tolerant have been developed and are currently being experimentally implemented. Yet, yet two two different approaches, quantum repeaters and ground to satellite, and being purchased in view to the profilation mobile computing device, including smartphones, mobiles applications, have been attracted further for the European Techno Communication Standard Institutes. We will highlight some of the above challenges in the various approaches that being be taken to tackle them. Thank you.